Welcome to this video on evaluating machine learning models, where we will focus on understanding precision, recall, and the F1 score intuitively. We must move beyond simple accuracy, as a high percentage correct doesn't always reflect the model's true effectiveness or utility. Accuracy is misleading because it treats all mistakes equally. In unbalanced data, like fraud detection, a 99% accurate model might miss all fraud cases. Also, in critical areas like medicine, a false negative can be far more dangerous than a false positive. To understand model performance better, we use the confusion matrix. This 2x2 map breaks down every prediction into 4 outcomes. True positives and true negatives are correct predictions, while false positives and false negatives are errors. A true positive, or TP, is a correct hit. You predicted positive, and the reality was positive. This is the success your model is built to find, like correctly identifying a sick patient as sick. A false positive, or FP, is a type 1 error, also known as the false alarm. You predicted positive, but the reality was negative. This is an unnecessary alert, such as legitimate mail incorrectly flagged as spam. A false negative, or FN, is a type 2 error and often the most dangerous. You predicted negative, but the reality was positive. The model quietly missed something important, like a security system failing to detect an intruder. Precision measures the quality and reliability of a positive prediction. It asks, of all the times the model predicted positive, how many were actually correct? High precision means you can be sure the alarm is real. Precision is calculated as true positives divided by the sum of true positives and false positives. The goal of optimizing for precision is to minimize false positives. Recall measures the coverage and sensitivity of the model. It asks, of all the actual positives out there, how many did we find? High recall is essential when the cost of missing a positive is high, and it means minimizing false negatives. Recall is calculated as true positives divided by the sum of true positives and false negatives. The goal is to minimize false negatives to find all actual positive cases. There is an inherent trade-off between precision and recall. Often, increasing a model's sensitivity to catch more positives or high recall leads to catching more false alarms or lower precision. The F1 score provides a perfect balance. It is the harmonic mean of precision and recall, which penalizes extreme imbalances, giving a single, balanced metric for overall performance. In real-world scenarios, the metric to optimize depends on the goal. For spam filtering, we optimize precision to avoid flagging legitimate mail. For cancer diagnosis, we optimize recall to avoid missing a case. This concludes our video on model evaluation intuition. The next topic will be overfitting versus underfitting.